Hi everyone, welcome back to VRC Smart Edu channel. So today we are going to see the chapter 11 alcohols, phenols and ethers. Okay, it is our organic chemistry part 3 of this chapter. Okay, already two parts have been completed and the links are provided in the description. You can go and check it out. And we have also completed another organic chapter, right? So we have completed the haloalkanes and haloarenes. The links of that also is provided in the description. You can go and check it out. Okay, so today we are going to see the preparation of phenols. So already we completed the preparation of alcohols as well as nomenclature and classification. Now today we will be dealing with preparation of phenols. Okay, preparation of phenols, and we will be seeing the physical properties. Physical properties means a boiling point. All these come into physical properties. Okay, so we'll see the preparation of alcohols. There are four different types of preparation for alcohols, and physical properties like melting point, boiling point, all these are coming under the physical properties. Okay, then solubility, all this. Next is structure of functional group. So if you are new to our channel, kindly subscribe to our channel and click the bell icon for notification. Follow our channel so that all the new notifications of the channel you can get it. So further we will be making new videos. Okay, and if you like this video, kindly hit the like button and let's move on to today's video. So preparation of phenols. So what is phenols? Already I told, phenol is nothing but the benzene ring. Benzene ring attached with OH is called as phenol, right? So phenols can be prepared by four types. Okay, so let us see how the phenols can be prepared. Okay, so phenols can be prepared from four types. First one, phenols can be prepared from haloarenes. Okay, first type is phenols can be prepared from haloarenes. Haloarenes. Okay, so what is haloarenes? Haloarenes. Haloarene is nothing but to the benzene ring if chlorine, bromine or iodine is attached. X atom is attached, that is called as haloarenes. So now I am taking chlorobenzene, right? Haloarenes we studied in our previous chapter. Now I am taking the chlorobenzene. What is this? This is chlorobenzene. To the chlorobenzene, we are adding NaOH. Okay. In the presence of H plus, in the presence of H plus and NaOH, it is going to produce ONA. Already we saw this type of, right? So ONA is going to be formed. That is, instead of Cl, we will be getting ONA. Right. So here what has happened? This is sodium phenoxide ion. Phenoxide ion is produced. Now what I am going to do is, I am going to react the equation with HCl, so that what is going to produce is, you see, this O is minus, negatively charged, and the Na is positively charged. H is positively charged, Cl is negatively charged. Now the O will be getting attached with H. As it is positively charged, H will go and attach to O. Na plus NaCl will be liberated. Na is positively charged. Being positively charged, will get attached with Cl and it will go out as NaCl. Therefore, your phenol is produced from this equation. Clear? So, first step, you can produce a phenol from haloarenes. Next step, you can prepare the phenol from. Second step, you can prepare the phenol from benzene sulfonic acid. Benzene sulfonic acid. Okay, so benzene sulfonic acid. So first what I am going to do for this equation is, first we are going to consider the benzene. Let us consider the benzene. So benzene is going to be reacted with H2SO4. This can also be called as oleum. Okay, so in the presence of oleum, you are going to get benzene ring with benzene ring attached with SO3H, right? SO3H you will be getting. Now again you are going to react the equation with NaOH, NaOH, NaOH. So you are going to get, listen, you are going to react this with NaOH as a catalyst. So you are going to get the benzene ring with OH attached plus, see, Na plus OH minus also you can keep. That will be getting replaced over here. So this is plus, this is minus will be getting attached over here. And plus NaHSO3 will be produced. NaHSO3 will be produced. Clear? Right. So third preparation is from, listen, third you can prepare from disonium salt. Disonium salt. So how you can prepare from disonium salt? Now listen here, first you are taking the benzene ring with NH2. What is benzene ring with NH2? Is called as aniline, right? Taking that, in the presence of, you are going to react it with NaNO2 plus HCl in the presence of 0 degrees Celsius. You are going to get the benzene ring with N2Cl, and further you are going to react it with warm water. So while you are reacting with warm water, you are going to get OH, that is a phenol attached. Phenol plus here N2 gas will be evolved, that is it will be evolved and going out as gas, and Cl will be going to attaching to H and forming HCl. Okay, forming HCl. Clear? This is from disonium salt. Next, if you are going, next you can have the preparation. Last type of preparation you can do is from cumin. Cumin is also called as isopropyl benzene. Isopropyl benzene. Okay. Now let us take the cumin. Okay, first let's take the cumin. So first I am going to have the benzene ring. To the benzene ring, the first position, here your C is going to be attached, and propyl in the sense 3C should be attached. Propyl, iso means the second carbon attachment should take place, right? So propyl in the sense 3. So second position you have to attach it with the benzene ring. Clear? So now fill it with hydrogen, CH3, single bond, so CH, single bond, CH3. So this is your isopropyl benzene or cumin. This is your cumin. When it is allowed to react with O2, that means you are oxidizing it. When you are allowed to react it with O2, you will be getting your benzene ring, okay, attached with CH3, and to this C what will be attached is OH will be attached. Now what happens is, to this is called as cumin hydroperoxide. To this cumin hydroperoxide, you are going to heat it. Or you are going to supply some heat energy. So that what is going to be produced is, so that your OH is going to be produced. OH will be produced with the liberation of CH3, CH3 double bond O. With the liberation of CH3, C double bond O, your phenol is going to be formed. So there are four different types of preparations you can do with phenol. One is going to be from haloarenes. That is, you are going to take the chlorobenzene and you are going to perform from haloarenes. You can perform the preparation. Second type, you can preparation you can do it from benzene sulfonic acid. Okay, first you are preparing the sulfonic acid, later reacting with NaOH, you get phenol. Next, you are going to use the diazonium salt. Okay, so NaNO2 plus HCl under 0 degree Celsius, you are going to react. Okay, so when you are reacting it with diazonium salt, you are going to get the phenol. Finally, when you are going to use the cumin, this what is cumin? Isopropyl benzene. We are going to use a cumin, you are going to oxidize it, then you are going to heat it, then you are getting the phenol. Clear? So look here, this is the physical properties of phenols and alcohols we are going to look after. So physical properties of alcohols and phenols. Okay, physical properties of alcohols and phenols. So let's see the physical properties in detail. So let me talk about the first point. Okay, see the first point. Okay, so physical properties, under that first let me discuss about the boiling point. So first we are going to discuss about the boiling point. So boiling point of alcohols increases when you increase the boiling point of alcohols increases when you increase the when number of carbon atoms, or the number of carbon chain increases, or the size increases. What happens? Carbon atoms or size increases. So when the carbon atoms, number of carbon atoms or size of the carbon atom or the chain of the carbon atom increases, the boiling point of alcohols increases. Your next point is going to be, okay, again we are going to talk about the boiling point. Okay, boiling point of alcohols, we saw about the increase of alcohols. Now we are going to see about the decrease in alcohols. Okay, so boiling point of alcohols decreases when branching increases. When branching increases. Okay, so next point is going to be the third point. The third point is going to be, listen. Okay, yes. So the boiling point of alcohols is going to be higher than other class of compounds. So okay, is always higher than other class of compounds compared to compounds. So compared to the alkanes, haloalkanes, haloarenes, hydrocarbons, hydrocarbons. Okay, so compared to the whatever you compare, see, when you compare the alcohols, haloarenes, hydrocarbons, ethers, whatever you compare to other class of compounds, the boiling point of alcohols will always be higher. Okay, so whenever your haloalkanes is given, haloarenes given, hydrocarbons given, ether given, alcohols given, arrange them in the increasing order of the boiling point. First you should start with the other class of compounds, because alcohols will be the highest. Clear? Next, fourth point. Okay, so fourth point is going to be the high boiling point of alcohols. We saw that alcohols are having high boiling point. So this high boiling point of alcohols, we are going to see what is that because of. That is a reason we are going to see for the higher boiling point of alcohols. So higher boiling point of alcohols is due to what? Due to the presence of intermolecular hydrogen bonding. Due to the presence of intermolecular intermolecular hydrogen bonding. So due to this intermolecular hydrogen bonding only, the boiling point of alcohols are much higher compared to other class of compounds. Clear? You see other class of compounds, you have the haloarenes, haloalkanes, all these things you have. But apart from that, what is having higher boiling point is alcohols. So that is having higher boiling point is due to the intermolecular hydrogen bonding. Clear? Next point is going to be, so the boiling point order. So the boiling point order is given over here. Okay. Boiling point of al for the order of the boiling point is given. First going to be the alcohols. Alcohols boiling point will be higher than ethers. Ethers boiling point will be higher than hydrocarbons. Okay, this is very important. Alcohols having the higher boiling point than ethers, having the higher boiling point than hydrocarbons. Clear? These 5 points are very, very important points. Let me recall these 5 points. First one, when the boiling point of alcohols are going to increase, the number of carbon atoms or the size or the chain of the carbon atom is going to increase. So when the branching increases, the boiling point of alcohol will decrease. The boiling point of alcohols is higher than the other class of compounds, right? Haloalkane, haloarene, hydrocarbons, ethers, etc. So your boiling point of alcohol is higher than the other class of compounds. Because of what? Because of the presence of intermolecular. This is very, very important keyword. Intermolecular hydrogen bonding. Okay. Next, the boiling point of alcohols. The order is also very, very important. For the some questions, they will be giving you certain compounds and they will be asking you to arrange you in the increasing or decreasing order of the boiling point. So for that you should know this. Alcohols will have a higher boiling point than ethers. Next, ethers will have higher boiling point than hydrocarbons, less than alcohols. This you have to remember, okay, for some variety of questions. Right. So now next, moving to the next topic called solubility. Solubility. Okay. So what is all about solubility? So solubility means how it will mix with the compound. Right. So solubility means how it is going to mix with the water. So solubility of alcohols and phenols, solubility in water, solubility in water. They are soluble in water. Why they are soluble in water means it is due to that is they have the ability to break the water molecule. That is a hydrogen bonding between them in the water molecules. So it can form the hydrogen bond with water molecules. That means what happens? It breaks the hydrogen. It has the strong enough power to break the hydrogen bond in the water molecule. Therefore, it can form the what? Bonding with the hydrogen. Okay. It is due to the ability to form. It's due to the ability to form hydrogen bond in water molecule. Hydrogen bonding in water molecule. Okay, that means it's nothing but it can break the water molecule and it can form the bonding with hydrogen. Clear? Now the solubility decreases. So you have said how it is soluble. So the solubility, when it going to be decreasing? So solubility, I am keeping it as yes, solubility decreases with increase in number of carbon atoms or carbon chains. Okay, so that is your solubility. So solubility content will be increasing. Okay, so decreasing when the number of carbon atoms or carbon chains are going to be increasing. So we studied that when number of carbon chains increases, the boiling point is going to increase, but the solubility is going to decrease. You remember comparatively. So when you remember comparatively, what happens? It will store in your mind for longer period of time, right? So the solubility is going to decrease when number of carbon atoms in chain increases, whereas the boiling point is going to increase when number of carbon atom increases, right? So your solubility will decrease. Clear? Right. So this is what about the solubility you have to remember. So why alcohols and phenols are soluble? So listen, here we are seeing the structure of the functional group. So functional group, we are just taking the alcohols. So alcohols is coming under one of the functional group, right? If you just look after the structure of the functional group, here if you just see here, listen here. So you just carefully observe this structure. If you just observe this structure, the angle formed between that oxygen and carbon bond is 108.9 degree. Actually, this angle is called as tetrahedral angle only. But usually, what is the normal angle for tetrahedral? Okay, usually if you are taking the tetrahedral angle, usually what will be the angle for tetrahedral? It will be nothing but it will be 109 degree. It will be 109 degree point 28 minutes. Okay, it is a normal angle of tetrahedral. But just compare this tetrahedral angle with this image. I have given here 108.9 degree. How the angle is varying, right? It's not the same angle. You actually this figure, the angle present in the figure is slightly lesser than the original tetrahedral angle. The original tetrahedral angle is more, but in the figure the tetrahedral angle that is shown is less. So why alcohols are having less tetrahedral angle compared to the original tetrahedral angle? That may be asked as a question. So actually it is due to the repulsion between the lone pair of electrons that are present in the oxygen. You can able to see here in the oxygen, there are two lone pair electrons are present. So you can say the repulsive interaction between the two lone pair of electron in the oxygen is going to cause the deflection in the angle between carbon and hydrogen of the OH, that is the alcoholic functional group. Clear? So how we can write the definition for this? How we can give the definition for this is, so you can write alcohols are slightly less, alcohols is slightly less than tetrahedral angle. Tetrahedral angle. So a tetrahedral angle is going to be 19.28 minutes, 109 degree point 28 minutes, right? So it is due to repulsion between unshared pair or lone pair, all are same. Unshared pair or lone pair, all these will be same. This is what unshared pair or lone pair of electrons. So pair of oxygen. So to the oxygen there are two lone pair of electrons. Pair is present. Lone pair of electrons are present. Because of that only, what is causing the repulsion is causing between the two lone pair of electrons. Therefore, what is happening? The tetrahedral angle is being reduced. Okay. Okay. So another one question can also be asked for you. If the question is something like this. Okay. Why bond angle in ether is going to be greater than tetrahedral angle. It's going to be greater than greater than tetrahedral angle. Okay. You should be very clear. See, if alcohols is given, alcohols will be having the bond angle less than the tetrahedral angle, but ethers are going to have the bond angle greater than the tetrahedral angle. You should be very careful over here. Okay, it is because, it is due to, or it is because the repulsive interaction between, the repulsive interaction between two bulky groups, two bulky groups attached to oxygen atom. Okay, so it is because the two bulky groups are attached to oxygen atom. You are having the oxygen atom in the center, and on the either sides two groups have been attached. You know how we named the ether, nomenclature of the ether, you know what is the general form of ether, all these things, right? So, because two sides are bulky groups are attached, so that the bond angle in ether is higher than the tetrahedral angle. So, ether means the bond angle is higher than the tetrahedral angle. Alcohols means the bond angle is less than the tetrahedral angle. This you have to keep in your mind. This is very important information where you can get confused. So, ether, higher bond angle. Alcohols, lesser bond angle. Compared to what? Compared to tetrahedral angle. So you have to remember that tetrahedral is 109 degree point 28 minutes. This also you have to remember. This is the original tetrahedral angle. Clear? So that's all for today's video. So thank you so much for watching this video. Kindly subscribe to VRC Smart TV channel for more videos, and let us meet you with the next video with the chemical properties of alcohols. So until then, bye from my side.